having had this plot for a while, I can know pretty well that the wind usually comes in three directions. So this one, and this one. I checked the data on this website using Newmarket as a guide, and this is called a wind rose, and it shows you the number of hours a year that you get a certain wind speed. So it didn't look quite right in terms of this number, 750. 750 divided by 24, it's 31 days, and my gut feeling was that it was more than that. So having then put in the exact location, I came up with this one, which is better, which is 1,000 hours, which is 41 days a year. You get these wind speeds. Now the direction, this is the direction the wind blows from, which is an important thing. So it's pretty much the same as what I thought here. They're slightly more this way than I was, but it's pretty close. So basically, if I click these greater than 31, greater than 24, greater than 17, this is the ones that are interesting. So anything above 7 mile/h winds, this is the shape. So that's pretty exactly the same as what I had figured. So the average angle of all these is kind of here, between southwest and west southwest. So the idea is to make a wind turbine that harnesses this wind, and it's in a fixed position. It's not like a vertical axis one. So on the drawing here, the position of this thing is not decided. This is just where I've put it for to show. So this is the wind coming in, and this is the Venturi, and this is a little flap which you're going to see in a model in a moment, which moves up and down. This is a little building which would probably need to be no bigger than a normal size height, like a 8-foot, 10-foot ceiling. This is an RSJ going across, and underneath it is suspended the turbine, and it hangs from that, and as the wind blows through, this turbine can swing back out of the way and slow down. The building would need a roof to keep the water off the electrical components, and it would need an opening which would probably need like metal bars, like a barred gate, to let the wind out but to keep people from going in there, because it's going to be dangerous inside. The Venturi is basically, I've been looking at this thing here. This is an Invelox turbine, which is the closest thing. Even though this doesn't look very pretty, the manufacturer claims that a 2 mile/h wind is enough to make it work. So I was looking at 7 mile/h winds in that picture, and the Venturi shape is drawn nicely here. They've got a straight section here, tapered section here where the turbine is, and then it gets wider. Now this is also possibly something which is very important, because there's another type of shrouded, not shrouded, but a skirted turbine, like circular motion turbine, and they claim the skirt actually causes a vacuum behind the turbine, and also behind the skirt, 2 places you get a vacuum, and this is evidently said to increase the speed of the turbine beyond what was possible without having a skirt. So I'm going to pay close attention to what happens after it goes through the turbine. This is a close-up of my wind turbine idea. The normal method of using this type is vertical axis like this, and because it's convex on one side and concave on the other, it spins regardless of whatever direction the wind's from. So my idea is to make this horizontal this way up and to shield one half of it, so the wind is only going on the concave side, thus making it faster. And this assembly here is to allow it to move out the way. I'm going to connect it up in a minute. And this is the Venturi here, and you can see there's a little flap on the end, and this will go up as the wind gets stronger, which will make the turbine move out of the way. This is the side view, a very rough drawing of what it would look like. I'm just going to zoom in a little here. Okay, so the height from there to there would be roughly 10 foot, or if I'm allowed to, maybe 12 or 15. And then the wind would go in here, obviously. And this is the ground. And this is a building of normal height, 10 or 12 foot, something like that. And this is the flap, which you're going to see working in a model in a moment. So when the wind comes in slowly, the gravity holds this flap down. As the wind gets faster, this flap will lift up because it's going to be hinged somewhere here, and as it lifts up, the wind will then hit against this blue thing, which is like a shroud and also a brake. So the wind will push down on this blue thing against the rim of the turbine, which may be like a rubber material, and it will push away, and the brake will slow it down. Now the whole point of this is to stop the thing smashing to pieces if a really strong wind comes through. And thinking backwards, this is also the position it would be if we had enormous gust come through. It would blow right up. There's a hinge here. This would be an RSJ going across the ceiling. It hangs down. This is the axle of the turbine which spins round. The wind would blow this right up here, and there'd be a ratchet pull here which clips it. So it'll blow up there and it will clip, and the wind will pass safely out of this opening at the back. And as I said, there'll be a roof on top, because inside there'll be belts and gears running to a little generator, which will probably have to be suspended on this apparatus. So that's how it's intended to be. Pretty simple, really. So gravity makes this pendulum return to vertical, and gravity makes this flap return to this position. So under a normal wind of kind of 7 miles an hour to 20 or 30, maybe not as much as that, but maybe 27 to 20, something like that, it'll be in its normal position, spinning away quite happily. But if anything violent happens, it moves out of the way and slows down. It may require some form of oil dampers, and it may also require like rubber buffers. If it swings back violently, we don't want it smashing into this, so there'll be some stops here to stop it smashing too much, maybe a spring. But it all looks pretty simple to make. So we switch on. You can see it's going reasonably slowly, and the little flap is lifted up a little bit. We want to see it slow down as I get closer. So we're going to move this closer. This is to simulate a stronger wind. Well, you can see it is going a little bit slower because the flap's a little bit higher. And I'm going to move it closer still. You'll see the turbine move away. Not quite stopping, but the action of the high wind is not destroying it. If I lift the flap up manually, you'll see the thing stop. Slowing down and then safely stopping. And then the normal wind returns and it starts up again. Okay, this is set up and this is to simulate the strongest wind, so it hopefully won't turn around at all when I put the fan on full power. You can see it's pushed it back, so the turbine is not getting any wind at all. Now I'm going to move it away a little bit so it looks a bit more normal. This will be a normal wind. So you can see it's turning quite slowly because a lot of it's just going up above the shroud. And we've got 27 or 28 revs per minute. I'm going to move it away a bit more. So as I make the breeze more gentle, the speed goes up. You can see there 54 revs per minute. Now I'm going to reduce the wind a bit more and it will get faster still. Now it's gone up to 69 RPM, 70, 72.